Okay, everybody, this is chapter 5, section 4. I believe it starts on page 313 in your textbook. So once again, while you're taking notes, might want to highlight things, and then if you need to catch up on notes, hit the pause button and get caught up, and then hit play again. Okay. We're going to learn today about two other ways to prove that two triangles might be congruent. So the first one, if you'll go ahead and highlight this postulate 5.3, called angle side angle, or ASA. Okay. This one is just another way, a shortcut of proving that two triangles are equal to each other. And if we could draw a picture of this, we're going to draw two triangles that are relatively equal. Okay. And in this particular one, ASA takes a way of proving two triangles are equal by having two angles that are equal and the statement in an included side, which means the side between the angles. Okay, so if I show that this angle and this corresponding angle are equal, and then I could take this angle and say it's equal to this angle. Okay, the included side is really the side that connects those two angles. So it would be this side. Okay. If I get this situation, I get the rule angle side angle. I can now say that everything in both triangles are going to be equal. Okay. So that's another way that we're going to learn, besides the side and the angle side angle. Another way, or I'm sorry, side angle side that we learned in the previous section. This is another way to prove triangles are equal. Okay. In this particular proof that they have down below, they've done everything here for you, but we just need to make sure that we take what we know about these kinds of figures. One, that you have vertical angles when this is kind of a bow tie looking thing. Okay, we're taking what they told me up here in the given, that I have a bisection going on. So BD bisects AE. But you need to make sure that you say that in your proof. We stated the angles are equal by the vertical angles there in the middle, but you have to write which angles are equal. These two steps could be done in a different order. Doesn't matter how you do it. But taking a look at what I've now got on my picture, I have angle side angle is congruent to angle side angle, all corresponding to the other triangle. So now my last step is to say that the two triangles are equal by angle side angle. Okay. So another tool, but we know what a bisector is. We know that when we see a figure like that, we can say vertical angles. Not a tough proof to do, and especially if you know your rules. And that's going to be in this case, angle side angle. Okay. If we take a look at this particular one, we have a couple other things that we need to just to identify right off the bat. First off, I've got ZX right here, and I know that that's going to be reflexive to both pictures or both triangles. Okay. So in step 5, it is the reflexive property. So I'm going to say that XZ is congruent to XZ. Okay. In this particular proof, then in the given that they gave us at the top, they were saying that this side and this side are parallel, and this side and this side are parallel. So need to show that so we can start remembering some of those keys that we need to have. Okay, so up here in the given, they've split that up into two pieces. So they've got WZ is equal to YX, that was given. Or I'm not sorry, equal, it's parallel. And then I got the other lines that are parallel. So WX is parallel to YZ. Okay. Now what they've done in number 3, they're saying WXZ is going to be equal to YZX. But they don't give us a reason. Now we got to remember, with parallel lines, one of the things we could think about are alternate interior angles. So that's why those two are equal, because remember, you would have a transversal now with these parallel lines here and here. Okay. So in this case, I could say that those are equal by alternate interior angles. Okay. But I can also then say it here. I could say these two are equal to each other by the same reason. So that's what they give here. I just need to identify the angle. So I'm going to go W, angle W, Z, X is equal to angle Y, X, Z. Okay, so remember, you got to use 3 letters. The vertex has to be in the middle. Now that you've got that, I've got, in this case, I've got this angle, this side, this angle, equal to this angle, this side, that angle. So that gets me angle, side, angle down here. Okay. So just, we got, this is one of the things we talked about earlier. We just got to make sure we got that. When we have parallel lines, one of the things we could think about. Okay. All right. In this particular picture here, we don't have to really do a proof, but we're going to write down things that we need to know or remember, tell, or show the things they've given us. Okay. First off, they tell us that PQ is parallel to TS. So this line up here, or the part of the frame up here, is going to be parallel to this bottom piece down here. Okay. They're also telling me that R is the midpoint of line PT. So line PT is this right here. R is the midpoint, so that means midpoint that I have PR is equal to RT. So let's write that down. PR is going to be equal to RT, and the reason for that is the midpoint. Okay. But we've also got the parallel lines up here, so I think that you can see that, hey, you've got a transversal thing going on. So that means I can use alternate interior angles. So if I'm looking at my transversal, this angle right here and this angle right here should be equal. So, and I'll just say angle P, really shouldn't, but I will, is equal to angle T by alternate interior angles. Okay. And then looking at that, if you're looking at the two, what we have to prove that triangle PRQ and TRS are congruent. That's this triangle and that triangle. So if you look at just those triangles, I think I have vertical angles right here. Okay. And so I could say here, got to be a little bit more precise here. QRT is equal to angle SRT. And that's by vertical angles. Okay. So taking all that stuff they gave you, what we figured out, we got this angle and this side and this angle are equal to this angle, this side, that angle. So the two triangles are equal by angle, side, angle. Okay. All right. So really a good problem there dealing with parallel lines. You need to remember what that is. You got a midpoint. You got to remember what that does. You got an hourglass, if you want to call it that, with the two triangles sitting on top of each other. So that's vertical angles. Just stuff that you really need to make sure I identify all the time. Okay. On the question right down below this, they give me some other things. First off, they told me in the problem earlier that ST was 12. They also tell me that the height of this triangle, STR, was like 10 point, I think 4. I'm going to round it up. So the height was 10.4. ST, which is the base of that triangle, was 12. They want me to get the area of that particular triangle. Okay. So remember, for area of a triangle is this. And so I can go 10.4 times 12 and divide that by 2. And I believe it comes out to like 62.4. Okay. So that's the area of one of those. If you want the whole window, then I'm going to go ahead and multiply that by 6 because there's 6 of those particular triangles. If I did that, then I'm going to get this. Okay, that'd be square inches, or yeah, square inches on that. Okay. All right. So that was down below, but I want to keep the picture available to kind of show what we're doing. All right. So that's the answer we get for one of them, but we gotta get 6 of them. Okay, this particular one, kind of same thing here. I'm not going to do this one because I don't like the picture very much. It's kind of hard to see. But you got lots of parallel lines, so that right off the bat, I'm going to think transversals. I'm also I got a measurement here. MN is 4. So this segment up here is 4. And they want to know how much wire I'm going to be able to put there, okay? So I'm assuming too some bisecting things with the cross pieces, these guys, okay? And the black area is what I had to find, okay? So that'd be something that's kind of a cool one, but I thought there was just too much going on. The picture's not that great, all right? Okay. Moving on. All right, if you go ahead here and highlight this theorem 5.5, angle, angle, side. Okay. This is the 4th triangle congruency that you should know now. It goes with side, 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 angle, side, angle, side, angle. Now you got this. This one gets a little tricky because it could be kind of looked at in different ways. But the big thing I want you to get is this statement, non-included side. We learned that ASA was the side was included between the angles. Well, now the side that's going to be equal is not between the angles. So if you take a look at this picture, I've got this corresponding angle B. Sorry, hold on. This corresponding angle B is equal to E. A is equal to D. Now those two angles are corresponding, but now angle, angle, side would have a side that's not between the angles, okay? So in this case, really, you know, this side is also not between the angles. So really you could have different sides might be equal. There's no kind of set way. So this one's a little bit different than the other 3 we've done so far. Okay. In this particular one, I'm not going to do the flowchart proof, and I usually do a 2-column proof on this. Well, they're kind of doing baby steps here. I've kind of got the same thing that they just showed in the example before. I got these 2 angles are corresponding and they're equal. They're giving me that this non-included side is equal. So my last step is really just saying this because they gave me everything I need for angle, angle, side. So that'd be the reason why those 2 are equal. Okay, so they gave me everything there. Okay. All right. If we just take a look at this really quick, I got this hexagon they want me to prove if they're congruent using all these triangle stuff. And so if you kind of look at that, you would see that you should be able to, all these different triangles, there's one way or another, all the different things that we can say this triangle down here at the bottom would be congruent to this guy up here at the top because it's angle side angle. You could do this one here is congruent to this guy here by side angle side. So you can kind of go all the way around and do all that. Okay. All right. But moving on. Taking a look at this particular one, if we could go ahead and draw a two-column proof. Okay. And let's go ahead and set it up with what they gave me. RQ is equal to ST, and RQ is also parallel to ST. And we show that with the arrows, okay, and we show with the equality, okay, so that was all given to me. Now, when you get these, when you get these different proofs, sometimes there's more than one right answer. So I'm just going to do a basic one, but kind of just discuss what I might have gotten a different way. Okay, first off, to me, it's a pretty squished up bow tie, but I can say that this is equal to that by vertical angles. Okay, so one thing that we just need to know, so angle RUQ would be equal to angle SUT by vertical angles. Okay. They also got parallel lines, so I got a transversal thing going on here, but I really got two. I'm going to draw this one, but really RT would be another transversal line. Okay, so remember when I have that, I could have alternate interior angles that are equal, so I could say these two angles are equal. So I could say angle TSU is equal to angle R. Wait a minute, sorry, I said that wrong. Timeout. Gotta make sure you get the vertex in there. Angle RU. Get myself mixed up. Hold on. I had it right the first time. Angle RQU is going to be equal to angle TSU. That's going to be by alternate interior angles. Okay? So if you look at that, I've got this angle here and here. I've got these angles here and here, and I've got a non-included side there and there. So I could say the triangle RUQ is equal to triangle TUS by angle side. Okay. Now I could have used the vertical angles again and drawn my transversal line that way, and I could have said this angle and this angle were alternate interior angles and still got an AAS or angle side doing that. So that didn't really matter. I also could have done it, and I would have been mad, but I could not have maybe used the vertical angles, but used the two sets of alternate interior angles. But if you look at that, that would be this, this, this equal to this, this, and this. That would have gotten me this as my answer. Okay, so really I had three possible answers there. Doesn't matter which one you pick. I just kind of went that way because we were learning it. Okay, we'd already learned ASA earlier. Want to practice this one. Okay, so hopefully that's not too confusing, but many different ways sometimes to do some of these proofs. Okay, all right. They did a flow chart proof down below. We're not doing those. We're really sticking with two column, make it simple, and everybody's doing the same thing. Okay. Down here, we're going to go ahead and fill this in. So first off, this one's a little bit different I'm just going to do it really quick. We did it in class, and I made kids think, but on a video, then we're just going to stick with what we got. I have to prove that this big triangle ADC is going to be equal to triangle BEC, the other big one, to kind of overlap, okay? In class, a lot of kids started thinking, hey, you know, you got this hourglass there. That's not going to help me do this, okay? So let's just take what they gave me and talk about the rest of it. So angle DAC is going to be congruent to angle BEC, okay? And that they split up the given, and then DC is going to be equal to BC, okay? So we're going to go angle DAC here is equal to angle BEC, and DC is equal to BC. That was given, okay? And it's only 4 steps, and we're trying to prove down here the 2 triangles are equal, right? So just really quickly to save some time, we sat there and looked at it. We started doing this vertical angle thing here with this hourglass thing, but they're not parts of the triangle that are going to help me figure out by rule how the 2 bigger triangles are equal. But if we look down here at this angle, that angle is really part of both triangles. It's part of ADC and EBC. So in this case, we go back to a rule that we usually only use for sides of triangles. Now the angles are equal to each other, so I could say reflexive property. Okay, so that means it's equal to itself. So if you look at it, we've got angle, side, angle equal to angle, side, angle. Okay, so kind of a new thing, using a property we've used a lot, but using it in a different way than we're not used to. Okay, so we got to throw that into our toolbox. Okay. Okay, so that takes us to the end of that, but we're going to do one little thing from section 5.5. So if you go to page 321, please. And at the bottom of the page, there's another theorem that we have to have. It's not too far. There's no real example here either, so we're just going to have to know it. We'll draw a picture to kind of illustrate it. But if you could highlight theorem 5.9, it's hypotenuse leg. It's another way to prove that triangles are congruent. Okay. Now, if you remember, a hypotenuse is the longest leg of a right triangle. So if you could draw 2 right triangles, please, looking kind of similar. And this theorem says that the hypotenuse and a leg, so the other 2 sides are called legs, are congruent to the hypotenuse and the same leg, or a corresponding leg, then I can prove that the triangles are congruent by hypotenuse leg. Okay, so really you got to make sure HL. H means it has to be a right triangle for me to be able to use it. I can't use it with anything else that doesn't have a right angle in it. Okay, we've done some other proofs where it had right angles, but it ended up being side angle side. Okay, that's just because the hypotenuses weren't congruent. But now if I do have that situation, I can use HL. Okay, so you've got 5 now. So on page 322, can you write this down in the notes section? So triangle congruency, you've learned side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay, now, so section 3 and 4 And this little bit in section 5, very important that we go back over and look at it, understand what they mean, understand what that will look like, and be able to kind of identify those in the proof. Very proof heavy here. But once again, if you're doing a good job, you've seen things before, you've been able to write it before, it should not be difficult. Okay? So study. All right, so do the classwork. If you've got issues, make sure you get a hold of me and we can get going on fixing stuff. Thank you.